This conference will now be recorded.
Yeah. Rajesh, are you able to create some dummy?
Yes, the diagram, architectural diagram I draw.
Can you share your screen and show me?
Yes. Don't have permission to. Please give the permission to share the screen.
Yes, Sanjog, you have the control to provide the screen sharing.
Okay, I have that control.
Yes, I got it.
Okay.
See, this is the one. This is the load balancer. Here, internet gateway. EC2 instances or in the security group inside subnet. Then we have database, which is access the EC2 instances or accessing the database.
Yeah, it is not looks good, looks correct actually. So
Okay.
today we are going to create that thing first.
Okay.
I'm sharing the screen.
Okay. I can see your screen.
See my screen, right? Okay.
Yes, I can see.
Okay. Let's open draw.io. Okay. So first component is VPC, right? So we can put VPC first.
Okay.
So the VPC name is suppose production VPC. Okay. Then we need subnet this thing, right? Suppose we have Income. Okay, suppose I have 8 setup subnets. So why I have created 8 setup subnets? Suppose this is my public subnet.
Mhm.
AG1. Okay, in availability zone 1.
Okay.
SG2.
Mhm.
Then suppose this is my application subnet. Suppose this is my database subnet.
Mhm. Okay. For database, we create a separate subnet.
Yeah,
Okay. Okay. Databases are in that subnet only.
yeah. Okay, this application database and this is shared service subnet. Suppose I've created one.
Mhm.
Suppose I want to launch some third-party software or something, I can
Mhm.
use this subnet. Okay,
Mhm. Oh, can you change the color? Yeah. Give the different.
yeah, so that it will be
Okay.
okay. So why I have
Mhm.
created two subnet for each group? Because I want high availability, right? If my one
Mhm.
zone, sorry, availability zone got failed, I have another
Mhm.
availability zone to serve. Okay.
Mhm. Yes. Mhm.
Now I can add something like this. Um, okay. So why I've added this thing? This is my route table for this.
Okay. Okay.
Okay. So there is one common route table I'm using. Suppose I can use in this way. Mhm.
The route table will be having the IP addresses, right? IP addresses of internet gateway, and then the subnets.
Yes. Okay. Similarly, we can add here also.
Mhm.
This side. Okay. So the basic components we have created, like VPC subnet route table, and I can add internet gateway. So only internet gateway is required for your public subnet, right?
Mhm.
Not anyone anywhere else.
Sanjog, internet gateway is used in the private subnets, right, to access to the outside world. It will be used in the private subnets or in public subnets as well.
Public subnet only, no? So private subnet we are using NAT gateway.
Okay, okay.
Okay, I can add a NAT gateway over here. You know about NAT, right?
Yes. NAT is this one, network access control is right. Transfer, packet transfer.
Hmm. So to give egress network connections inside your EC2 boxes, we're using this component, right? So from in private subnet, from EC2's instance, suppose you can access to google.com. Okay, because there is no active connection, right? So you can access to. So generally, NAT gateway sits inside some public subnet. Okay.
Okay.
Okay, I'm just showing that as deep red. Okay. Okay. So now it's clear, right?
Mhm.
So all my private routable talking to NAT, okay, and NAT is talking to internet, and my public routable is talking to internet gateway. Okay. So these are the so we have completed. We have added most of the services over here. And endpoint services is VPC bounded. So we can add in this way. Suppose you are using S3 endpoint, you can add this S3 endpoint. Okay.
Okay.
So these are the different network component we have created. So this is the basic network diagram. So we have 8 set of private subnets, 1 set of public subnets, and we have internet gateway, NAT gateway, and we are using S3 endpoints.
Mhm.
Okay. So this type of diagram needed in companies actually. Okay.
Okay.
So before proceeding with any, so we have discussed key what components we need. Okay. So you need to break it down to different. So you need to first propose the network components. So we need this much network components. Okay. and then you need to propose some your compute part, how EC2 and data, how EC2 and MySQL connected to each other. Okay, and in which
Okay.
subnets where I am going to launch my EC2. Okay, on which subnet I'm going to launch my databases. So those things we need to fill it over here again. Okay, so this is I'm sending you this base diagram. Okay,
Okay.
and your job is to fill these things, compute and data inside that. You can do
Okay.
it, right?
Yeah, I can do it. The thing is, how for example, what is the instance size? Means what type of instance we will use? How many servers will be there inside the subnet? How to
No,
find out that?
first. So this is representative only. Okay, if we are going to 50 instances, no need to add 50 over here.
Yeah,
Okay,
yeah, yeah.
so only representative, and instance type is so so how you are going to choose instance type?
Depends upon our traffic. We have to choose.
Traffic and application also. If my application is taking more memory or more CPU, okay, or my application is a general purpose application, means it is taking standard CPU and standard memory. Okay,
Okay, let's say
so
yeah, the MST, there are 2,000 users, 2,000 employees will use the time tracking application. Let's say. Then
okay,
what would be the
so generally in that case we are choosing C5 series. Okay,
okay C5? Okay.
okay, AWS EC2. Mm, not T series. So don't use T series anywhere because it is for your staging and dev environment. You can use for production. Always go for compute optimized instances. Okay,
Okay.
because
Okay.
we need compute in our for our general purpose applications. Okay, where we are getting the CPU and memory ratio is 1:2.
Okay. Okay.
For our applications, so these components are required, but we have not did a capacity planning for it. Okay, now I got ki 2,000 or 5,000 user are going to use this application, and they are going to use from wait, so they are going to use from morning 9 to mostly I'll get traffic morning 9 to night 10 o'clock. Okay, so for that kind of scenarios, okay, we need to do a capacity planning. Okay, so how many EC2 instances I need, what is the size of that? So we decided ki we'll go for C5 4x large, suppose, or C5 2x large. We can start with this thing. Okay, then because our application is horizontally scalable, okay, and we can start with C5, suppose 2x large, 8 core 16 GB memory wala machines, or C4x large, 4 CPU 8 GB machine. We can start with a minimum one actually. After that we'll increase it. Okay, so now we'll discuss key architecture diagram. You need to put all databases and EC2 instances inside it, or uh, should I put it now?
Inside the public subnet, we need to add some add instances, and then we have to connect those instances
Public
with the
subnet, the
database.
load balancer will subnet, your load balancer will come. Application subnet, your EC2 instances will come. In DB subnet, your RDS will come. Okay, you need to do a network flow. So how traffic coming to your public load balancer, then from public load balancer, how it is coming to application subnets, how application subnets is coming connecting with DB subnets. Those diagram. Can you add those things?
Sorry, I don't have much idea on this one.
So you can try, na?
Yeah, I will try. Yeah, I will try.
Put ALB inside it.
Uh-huh.
Okay. From ALB, create a ASG over here, auto scaling group.
Okay.
From ALB, traffic will come to this ASG, and from this ASG, traffic will come to some RDS instances over here. So suppose some Elastic Cache and MySQL RDS instance is there. So from this EC2 fluid, we are getting some RDS instance.
Okay. In the public subnet, only we will be having a load balancer.
Yeah, and all things are in private subnet.
Okay.
Okay, this is the only public thing
Okay.
in our infrastructure. So you can
Okay.
tell my VPC is having only 2 public subnets where I am launching my load balancers. I'm not launching my applications, databases, shared things on any public subnets. All are in private subnets.
Okay.
So by doing in this way, na, you have added first layer of security. Okay. So any attack happened, anything happened, na, you have that control. You can disconnect your traffic from ELB level.
Okay.
And your application DB subnets are in private network, so nobody can attack it. Okay, outside. So they can come to your application via a public subnet load balancer. Okay. So people will ask you how you are going to access your application subnets instances if they are in public, private, right?
Yes.
So if they are in private, you need to access from your local also, right? For development. So how you are going to access?
For that, if you want to apply, if you want to access the application which is in the private subnet.
Yes.
This is internet gateway.
No, dude. Internet gateway is for public subnets. So if I attach my subnets to internet gateway, they become public. Okay. My outgoing egress traffic is coming from private gateway. There is no internet bound traffic is coming. Subnet to subnet communications are there only. And outgoing traffic is going via your NAT gateway. Okay. Suppose from this application subnet, from a private EC2 instance, you want to call google.com. That traffic will go via your NAT gateway. Okay. And if I want to access www.timetrackingapp.com, that traffic will come via your public internet. Okay, this internet gateway, and lands on your load balancer.
Yes.
Got my point. From this load balancer is having some target groups.
Yes.
So those target groups are actually your application subnets EC2 instances. So based on the health check, it will forward traffic to application subnets instances. And application subnet instances, these are suppose Java based applications, Spring Boot applications. Internally, they are calling your database systems like Elastic Cache and MySQL. So this is the traffic flow, end-to-end traffic flow.
Okay. How one private subnet will communicate with another private subnet? Through which?
So these are in a single network, right? VPC is providing you a single network.
Okay. Yes.
So I'm just showing you. Understand?